Okay, so far we have done gravimetric stoich and solution stoich. Now we are going to look at gas stoich. So gas stoich, I would say, is probably the more complicated of the three, and that's because there's three different ways to do gas stoich. Why there's three different ways? It depends basically on what kind of conditions we have in determining what we are going to do. So first scenario we have is for gases at the same temperature and pressure. So for these types of questions, we're generally going to find that we have two gases and we're converting from volume of one gas over to volume of another gas. So what we can do in that case is create a volume ratio. Okay, and we create a volume ratio the exact same way we do a mole ratio. So important to recognize this whole volume ratio only works when you're converting a gas volume to a gas volume. It does not work for solution to solution, only for gases, okay? And we will revisit this when we are actually in the gas unit, but let's show you a quick example of what this is going to look like. So in the combustion of propane, what volume of oxygen will be consumed if 2.50 liters of propane gas is burned? So we have propane, which is C3H8. Okay, propane is what you use in your barbecue. It's a gas. Combustion, so plus oxygen. And we are going to make carbon dioxide as gas, as well as water as a gas. All right, we need to balance this. So there's 3 C's, so 3 over here. There's 8 H's. So 4 in here, and then based off of that, we have 10 O's on this side, so we're going to need 5 over here. So we are looking for the volume of oxygen, that is our unknown. We are told that 2.50 liters of propane burned. So in this case, I have a volume of this gas, and I'm looking for a volume of this gas. So this is a scenario where I'm looking for that volume of oxygen. I can use a volume ratio. So the volume ratio, I would generate the exact same way I would a mole ratio, right? If I was trying to make a mole ratio between these two, I would have said 5 moles of oxygen to 1 mole of propane. Literally all we're going to do is switch it to be liters of oxygen and liters of propane. So because we are trying to solve for volume of oxygen, we're going to put the 5 liters of oxygen on top. Okay, on the bottom of our ratio, we're going to put the 1 liter of that propane. Okay, so there's our ratio. It's a volume ratio instead of a mole ratio. We now need to get rid of liters of C3H8. So to get rid of it, we're going to place that on top. So we're going to do times 2.50 liters of propane. And we can just put that for 1. Now we have a look at those units. We can get rid of liters of C3H8. We're left with liters of oxygen. So we're literally just doing 5 times 2.5. So we get 12.5. Okay, just like before, ratios don't count for significant digits. So 3 significant digits because this volume had that. Okay, so these are the simplest type of gas stoich. We're going from a volume to a volume. We're just going to make a volume ratio just like we would a mole ratio. So usually you will know that this is what you're doing because you're literally only going to have this given. There's going to be no other given to you in the question. Okay, second type of gas stoich. This one is definitely more complicated and your stoich or unit analysis is going to get much bigger. So when gases are at different temperatures and volumes, or more or less you're taking a mass and converting to a volume of a gas, or you're dealing with a solution and converting to a gas. So usually this is what we're using when we're not just going from a gas to a gas, we're going from a different state to a gas. We're going to have to use some additional pieces. So one of them is the gas constant R. And we're going to again talk more about this when we get into the gas unit. But R is a constant, kind of just like when you were in grade 10 and we talked about like, oh, gravity is always 9.81 meters per second squared. Now we have R as its own constant. So R is 8.314 kilopascals liters per Kelvin mole. Okay, this mole, just like anytime we have mole in our stoich, we're always going to want to write next to it what it is. And this is always going to be associated with our gas because it's the gas constant. So Kilopascal is what we use to measure pressure. So you're going to find these questions are going to tell you what the pressure is. Liters, it's volume, it's nothing new there. Kelvin. So Kelvin is how we generally measure temperature in chemistry. Sometimes we use degrees C, but when we're in gases, we don't use degrees C. And that's because, think about when it's cold outside, right? It could be 0 degrees. Does that mean gases have no volume? No, it doesn't, right? But if I did a math calculation with 0, I would definitely get 0 as my answer. Same deal if it was a negative number, that would tell me a negative volume. Well, obviously that doesn't happen because it was in the negatives not too long ago. Everything still existed. So instead we use the Kelvin temperature, the absolute scale. So to be able to do these types of questions, what you're going to have to do is take a degree C and convert it over to Kelvin. So here's a little equation for you to do that, and that's that your temperature in Kelvin is equal to your temperature in degree C plus 273.15. Okay, again, it's usually pretty obvious that you need to convert your units because when you look in here, there's no degree C, it's Kelvin. And really when you're focusing on those units, it makes it a little bit more obvious what you need to do and where you need to go, okay? So yeah, these questions are definitely going to be bigger. If you think about the examples we've done before, they've kind of ranged anywhere from 2 to 4 things being placed in our unit analysis, and these ones are going to have significantly more. You'll know though that that's the kind of question you're doing because it's going to give you a temperature and it's going to give you a pressure. Every other question doesn't do that. So here's an example of that. So what volume of hydrogen gas will be produced at 93 kilopascals and 23 degrees C from the reaction of 50 milligrams of magnesium metal with sufficient hydrochloric acid? So stepwise doesn't change. We have magnesium combining with hydrochloric acid. Okay, this is a single replacement reaction. So we are going to make hydrogen gas and then magnesium chloride, which if we check our solubility table, is going to be aqueous. Balancing wise, we need a 2 in front of that HCl. I'm just going to spread it out a little more so that I can write some of these givens in. Okay, so we are looking for the volume of hydrogen gas. So this is what we are looking for. So we are given a pressure and we're given a temperature. Those all get associated with the gas. So 93.0 kilopascals. Okay, we then need to convert that temperature over, right? And we just said on the last page that you would do that 23 plus 273.15. So from that, we get 296.15 Kelvin. Okay, so we're going to carry the whole number through as we do our calculation, but we do want to be considering our significant digits. So where some of you guys kind of get a little messed up sometimes with the temperature is you look back at the question, you're like, oh, it had 2 sig digs, but I did an addition with it. When we do addition, it's about decimal places, right? So this had none. So technically these don't count. But that still leaves me with 3 significant digits. So really it's the Kelvin temperature that I want to look at for significant digits, not the degree C. Okay, so now that I see that I also have all of these givens listed, I'm going to need to use that universal gas constant, so 8.314 kilopascals liters per Kelvin mole. Okay, you're going to find all your gas stuff is given to you. Okay, we don't expect any memorization of that, unlike some of the solution stuff like the pH and the pOH. And that's because really gases don't carry through into Chem 30. So there's no point in memorizing them if you don't actually have to use them next year. Okay. All right, so we have all of that. Other thing we have is a mass of magnesium. It was 50 milligrams. So we divide by 1,000 to get grams. So 0.050 grams. Because we have a mass, we're going to need a molar mass, which for magnesium is 24.31 grams per mole. Okay, so now we start our unit analysis. So to do this, same steps as always, but you are going to find there's going to be more things going into your unit analysis. So we are looking to solve for volume of hydrogen. Volume has units of liters, right? So kPa, no. Kelvin, no. Oh, liters. There we go. So we are going to start with the universal gas constant. Liters is already on the top, so that's perfect. We can use it the way it is. We're going to go 8.314 kilopascals liters, and we're going to write this over Kelvin mole. And next to mole, we always write what it is. So this is going to be moles of hydrogen, okay? You're always going to find that this 8.314 is always going to be moles of whatever the gas is. It's not going to be moles of something else because it is a gas constant. So we have a bunch of units to get rid of, right? Ultimately, the only thing we want is this liters. So we need to get rid of kilopascals, we need to get rid of Kelvin, and we need to get rid of moles of hydrogen. So let's go ahead and get rid of those kilopascals. They're currently on the top. We're going to need to place them on the bottom. So we're going to do 1 over that 93.0 kilopascals. Okay, and doing that, we've now eliminated the first unit we don't want, right? We got rid of kilopascals. Okay, so we still have liters, but we still have Kelvin and moles of hydrogen. So we need to get rid of Kelvin. We can get rid of Kelvin by using the temperature. So because Kelvin's currently on the bottom, it needs to go up on the top. So we're going to do times 296.15 Kelvin. And that's going to go over 1. Okay, so now we have eliminated the Kelvin unit. So next unit to get rid of is going to be moles of hydrogen. And so we don't have moles of hydrogen. This is where we're going to use that ratio, right? We always use a ratio in our stoich. So we're going to do times 1 mole of hydrogen over 1 mole of magnesium, right? Hydrogen is what we're looking for. Magnesium is what we have info for. So from here, we can now cancel moles of hydrogen. Next thing we need to get rid of is moles of magnesium. So we find magnesium over here. Here's that moles. So we're going to take the molar mass and we are going to flip it over. So we're going to do times moles of magnesium over 24.31 grams. Okay, so now we've eliminated another unit. We've gotten rid of moles of magnesium. Last thing we need to get rid of is the grams of magnesium. So we're going to times by 0.050 grams. And again, we're just going to put that over 1. Now when we have a look at all of those units, we got rid of grams. Everything is gone. Just the liters is left, okay? So most common mistake you guys tend to make with questions like this is you forget to write what this is moles of, and then you leave your ratio out. So in this particular question, because it's a 1-to-1 ratio, I would still get the right answer in the end. I wouldn't, if it was a written response, get full marks for the question because my unit analysis would be missing a piece. But if it was a numeric or a multiple choice, right, where literally the only thing that matters is your answer, then you would get the right answer. But obviously if it wasn't a 1-to-1 ratio, then that would be a different situation. You wouldn't be getting the right answer. So really important to make sure you don't forget to use that ratio when you are doing these questions. Okay, so 8.314 divided by 93 times 296.15 divided by 24.31 and then times by 0.05, we come up with 0.0545 liters as our answer. Okay, so this is kind of the messier gas stoich, I would say, because it's the biggest and the longest and it takes the most time and there's the most things to go into it, right? The previous one where they were both gases and I was just switching volumes, I only needed a ratio. It was nice and simple. So again, although we talk about this in the stoich unit, we definitely do revisit this in the gas unit. All right, so third type of gas stoich. It's kind of, I don't want to say it's a mix between the two, but it's definitely not as big as the last one. It looks more like your standard type of stoich question. So these would be for gases that are either at STP or SATP. Okay, so STP stands for standard temperature and pressure, and SATP stands for standard atmospheric temperature and pressure. And these are two sets of like constant temperature and pressure conditions where we have some extra numbers pre-calculated because they're commonly used temperatures and pressures in chemistry. So in questions like this, you can use these numbers here. So you'll find that when you read the question, it'll either say that the gas is at STP, and then you'll be able to use the 22.4 liters per mole for your gas, or it'll say the gas is at SATP, and then you use the 24.8 liters per mole. Okay, if it's not an STP or SATP question, it won't use those abbreviations. It will give you kilopascals and degree C, or it'll give you a volume and ask you for another volume. All right, so looking at an example of what this looks like. So what volume of oxygen would be required for the combustion of 8.50 grams of octane at STP? So octane, C8H18, it's a liquid, right? This is what you use in your car. Plus oxygen. And this is going to give us CO2 and water. Okay, we need to balance this. You'll find if you try to use just one of the C8H18, you're putting a 9 in front of the water, which gives you an odd number of oxygens, which makes it so that you can't actually balance it because this is O2 and you need an even number. So you need a 2 over here, you need a 16 here, and an 18 here, 25 over here, okay? So what do we have? We have a mass of octane as 8.50 grams. Because we have a mass, we're going to need a molar mass. So 8 times 12.01 plus 18 times 1.01. We get 114.26 grams, and that will be per mole. All right, so for our gas, which one are we looking for? The volume of oxygen, right? So we are looking for the volume of this. We are told it's at STP, right? If we look back at the previous slide, our STP value was 22.4 liters per mole. So we're going to associate that with our gas. We're going to say 22.4 liters per mole. Okay, make sure you write it as liters per mole. Sometimes you guys want to write it as moles per liter because that's how we do concentration. But this here is molar volume, and so it's liters per mole. Again, when we're in gases, we'll spend more time talking about that. So this question is a little bit easier than the last one. Oh, that's a little messed up there. Let's fix that. Okay, so we are looking for the volume of oxygen. We find oxygen. Oh, look, it has liters under it. It's already on the top. Perfect. So we're going to start with 22.4 liters, and that's going to be per mole of oxygen. Okay, we need to get rid of moles of oxygen. How do we get rid of moles of oxygen? We're going to use a ratio between the two. So we're going to say times 25 moles of oxygen. And we're going to divide by 2 moles of that octane. Okay, this is going to allow for us to cancel out moles of oxygen. Now we need to cancel out moles of octane. So we look at octane, it's right here. Here's moles, so we're going to take the molar mass and we're going to flip it. So we're going to do moles of C8H18 over that 114.26 grams. So next unit we've just canceled in doing that is that moles of octane. Last unit to get rid of is the grams of octane. So we can just times by that 8.50 grams, put that over 1, okay? So now we have a look at our units. Everything cancels, just a matter of plugging this into our calculator and getting our answer. Okay, so type that in our calculator, 22.4 times 25 divided by 2 divided by 114.26 times 8.5, and we should get 20.8 liters, okay? So those are your 3 kinds of gas stoich. Again, we will revisit these when we are in the gas unit. They're not going to be in Chem 30. So I would say if you're kind of struggling with them, it isn't really the end of the world, right? The bigger pieces to focus on are going to be that solution stoich, that gravimetric stoich, and then some of the other lessons that are still to come.